Hello there, Harry Cliff here. An experiment at Fermilab in the United States has just released a very exciting new result that could be hinting at the existence of a brand new force of nature. Specifically, they found the magnetic field produced by a particle called a muon is different from what we'd expect based on our current best theory of particle physics. Now, combined with the anomaly seen by the LHCb experiment a couple of weeks ago, it's starting to look like we could be on the brink of a major breakthrough in our understanding of the universe. Muons are fundamental particles, a sort of heavy, unstable version of the more familiar electron. They have an electric charge and they behave a bit like little bar magnets. And the important thing is that the strength of those little bar magnets depend on what other particles exist in nature. Here's why. Particles are not the fundamental building blocks of the universe. Yes, despite the subject being called particle physics, the real building blocks of the universe are fields. No, not that kind of field. I'm talking about quantum fields. Quantum fields are invisible, fluid-like substances that fill the entire universe, and every particle in nature is just a little ripple sloshing about in a quantum field. The electron is a little ripple in something called the electron field. The muon is a ripple in the muon field, and so on. These quantum fields are always there, even when there are no particles sloshing about in them. So if you plop a muon into the vacuum, it interacts with all the other quantum fields that are hanging around, and they change its properties. In particular, they change its magnetic field. So the magnetic field of the muon is dependent on all the quantum fields in the vacuum, including ones that we've never seen before. The basic idea is, if you make a fantastically precise measurement of the muon's magnetism and compare it to an equally precise theoretical prediction, and you find a difference, that could be the clue to the existence of new fundamental particles, even ones that are too heavy for our most powerful particle colliders to produce. Back in 2001, an experiment at Brookhaven in New York found that the muon's magnetism was different from what theorists had calculated. Now, this got physicists very excited, but the result wasn't precise enough to be sure that the effect was real. So, the giant ring used in the experiment was shipped 900 miles across the United States to Fermilab near Chicago and installed in an upgraded version of the experiment whose mission was to resolve the mystery once and for all. Today, the experiment released their first measurement, and excitingly, the anomaly is still there. And what's really going to get physicists hot and bothered is when you combine it with the result from 20 years ago, there's now only around a 1 in 40,000 chance that this effect is a random statistical fluke. However, that's still quite a long way short of the 1 in 3.5 million chance that's required as the gold standard to announce you've really discovered something in particle physics. Fortunately, in the coming years, the experiment should be able to improve its precision by about 4 times, allowing it finally to confirm whether or not this effect is real. So what does this all mean? Well, this is yet another piece of evidence that we could be on the verge of discovering a brand new ingredient of our universe. It's still too early to say for sure, but whatever happens, we're in for an exciting few years in particle physics.